In the 2011 higher level paper, for question 1, our titration, we can see that we're given the bleach titration, where we need to find the concentration of hypochlorite in bleach. Now this titration is a little bit more involved in terms of the ratios than the other titrations calculations are. So we're just going to go through this step by step and see what we have to do. So a chemist determined the concentration of a bleach solution containing sodium hypochlorite by volumetric analysis. A 25 ml sample of the bleach was first diluted to exactly 500 ml. So that right there is important. The bleach was diluted to 500 ml. And that's important because we now have a dilution factor. So the dilution factor for the bleach is we went up to 500 ml from 25 ml, and that works out to be 20. So my original bleach is going to be 20 times more concentrated than the diluted bleach we use further on. So a pipette was used to measure a 25 ml volume, so 25 ml of diluted bleach. That's this chemical here, the hypochlorite, and transferred into a conical flask. Solutions of potassium iodide and sulfuric acid were added. The following reaction took place in the conical flask. The solution in the conical flask was titrated with a 0.1 molar solution of sodium thiosulfate. So 0.1 molar solution of sodium thiosulfate. That's this stuff. The average volume of sodium thiosulfate required when the procedure was repeated a number of times was 16.1 ml. So that's still my sodium thiosulfate. The balanced equation for the reaction was that, and we were asked to find the concentration of sodium hypochlorite in moles per litre in the diluted bleach and then in the original bleach. So we can see that we're asked to find the concentration of the sodium hypochlorite in moles per litre, but we don't have an equation that has sodium hypochlorite and my thiosulfate in it at once. So I'm just going to need to link up the ratios to begin with. So if we look at the two equations, we can see that what links them is the iodine. Iodine appears in both. So if I set up a ratio between thiosulfate, iodine and hypochlorite, we can see in the second equation that the ratio between thiosulfate and iodine is 2:1. And then if we look at the first equation, if I have 1 iodine, I must have 1 hypochlorite. So in reality, my ratio between thiosulfate and hypochlorite is just 2:1. And that's the ratio we're going to use further down in the question. That's what we're going to need. So we'll get on with the calculation now. So calculate the concentration of sodium hypochlorite in moles per litre in the diluted bleach. So for E part 1, I'm going to start as I normally would with the concentration I know. And I know I have a 0.1 molar solution of thiosulfate. So I have 0.10 moles per litre of thiosulfate. Did I use a litre of thiosulfate though? No, I only used 16.1 ml. So to find how many moles of thiosulfate are in 16.1 ml, I'm going to divide by 1000 and multiply by 16.1. And that gives me 0.00161 moles in 16.1 mils of my thiosulfate. Now to convert my thiosulfate into hypochlorite, I can use this ratio that I'm after finding. So I have thiosulfate is to hypochlorite is 2:1. So if I have 0.00161 moles of thiosulfate, I must have half as many moles of hypochlorite. So that's many moles of hypochlorite were my dilute bleach. So I had 0.000805 moles per, how much bleach solution did we use? We used 25 mils of the dilute bleach. So that's moles per 25 mils of my hypochlorite dilute. But it asks for moles per litre. So to turn that into moles per litre, I need to divide by 25 and multiply by 1000. And we get 0.0322 moles per litre of hypochlorite dilute. So that's E part 1 finished. But now I need the concentration in moles per litre in the original bleach. So we know from the very beginning that the original bleach is 20 times more concentrated than the dilute bleach from my dilution factor. So all I need to do is multiply the concentration of my dilute bleach by 20. So 0.0322 times 20 to make it 20 times more concentrated is 0.644 moles per litre of hypochlorite in the original bleach. So that's E part 2 done. Now for F. So what is the concentration of sodium hypochlorite in the original bleach in grams per litre? So F part 1, I need to convert this into grams per litre. So to convert to grams per litre, I need to multiply by the molecular mass of sodium hypochlorite. So that's going to be a 23 for sodium, 35.5 for chlorine, and a 16 for oxygen. And that gives 74.5 in total. So I need to take my 0.644, multiply it by 74.5, which is the molecular mass, and that gives me 47.978 grams per litre of sodium hypochlorite. That's F part 1 finished. And then it wants that concentration as a percentage weight per volume. So to convert this to a percentage weight per volume, first we're going to write down what that means. Percentage weight per volume means grams per 100 mils. I already have grams per litre, so all I need to do is take my 47.978 and divide it by 10. And I get 4.7978 grams per 100 mils of sodium hypochlorite. So that is a 4.7978% weight per volume solution.